This video is going to help you prepare for your GCSE Physics CAP test. First thing to know about your GCSE Physics test is that it's an hour and 45 minutes long and it's worth 100 marks, and it's going to be paper 1 of the physics papers. You're going to need some basic equipment for your exam. So as normal, you're going to need a black or blue pen. Make sure that you bring a spare just in case your pen runs out. You're going to need a pencil, ruler and rubber, because in your exam you will be drawing a table, a graph or a diagram, and you need to make sure that you do that in pencil so that you can rub this out in case you happen to make a mistake. You need a calculator, and ideally that needs to be a calculator that you're familiar with so that you know how particularly to do things like standard form on that calculator. And specifically for your physics exam, you're going to need to bring a protractor with you. So on paper 1, we look at 4 different topics: energy, electricity, the particle model of matter, and atomic structure. Further on in this video, I'll go through some hints and tips for each one of those particular topics. So the first thing is how to revise properly, and that starts off with PLCs, the Personalised Learning Checklist that my classes are used to using already, and that helps you to identify what you do and don't know. Most efficient revision comes from trying to revise what you don't know rather than spending lots and lots of time going over what you do already know. The next step to our revision is focusing one of those areas that you don't know and trying to learn the knowledge for that topic. So you need to break down the information that you have into the key points of knowledge. You can do that using revision cards, question and answer sheets, mind maps, learning maps. Any one of those will help you do this. And you can use your revision guides or knowledge organisers to help you with this. Then you need to test that knowledge, and this is a key difference to exam questions. So when we test knowledge, we're not trying to do an exam question, we're testing whether we've memorised those key facts or not. And again, you can do that with your question and answer sheets because you can try and do the answers. You can do that with your revision cards because you could try to write those out from memory. Once you've then got that knowledge, that's the point to then try your exam questions and where your exam technique comes in. And then the last point is that you need to retest this knowledge regularly, because if you've just learnt it on, say, a Tuesday, by the Tuesday of the next month you might have forgotten it. So we need to make sure that we're going over that knowledge, just 5 minutes going over things that you've already know, so that you make sure that that knowledge doesn't get forgotten. So things to help you: revision guides and teams. Make sure that you've got your revision guide and that you're using it efficiently. That means that, thinking back to the previous slide and how we do our revision, we're not going to start at the beginning of our revision guide and just read through the book. That's not an effective way to do our revision. So we need to make sure that we're making our revision as efficient as possible. To help you with that, not only is there your revision guide, but there's information on teams for you. So there's personalised learning checklists are there are knowledge organisers, mind maps, learning maps. There's a PowerPoint with equations to memorise. We've got required practical PowerPoints on there, revision notes, flashcards, and practice exam questions per topic. So if you can't find any of those, make sure that you ask your physics teacher and they will direct you to the right place on your Teams page. First thing when we're looking at exam technique is to read the question carefully. The question actually tells you all the hints you need to know to build up your answer to that question. So the first thing to look for when you're looking at a question, and this is just a broad example of a question, is to think about the number of marks that are available. That's going to tell you the level of difficulty of the question. Is it a 1 mark? Is it a 6 mark? Because you're going to have to write a lot of different information depending upon whether it's 1 or 6 marks or anything in between. The second thing to think about is what we call the command word in the question. What is that question asking you to do? Is it asking you to state something? If it is, you're probably just using something that's already given in the question or is from that knowledge that you've remembered in your revision. If it's asking you to describe, it might be a statement with a little bit more information. An explanation might be a statement and then a following sentence explaining why that sentence actually works or that fact. Okay, if it's a calculation question, you might be looking at the different skills in that calculation question. So it might be, do I have to just substitute numbers into the question and get an answer for 2 marks? Or it might be 3 marks where I might have to convert a unit, or I might have to rearrange that equation. If it's 4 marks, I might have to do something extra. I might have to give my answer in standard form, or I might have to give a certain number of significant figures. All of this information can be found in the question. So read the question carefully to help you look for the answers. The next thing, drawing graphs. It is likely that you will either have to draw a graph or you will have to interpret a graph for patterns. If you have to draw a graph, make sure that you're labeling the axes, but you're plotting the data correctly. So we will have to check the data on your graph to make sure you plotted it correctly. So do be careful with that. Make sure, like on the example below, that you work out what each small square in the graph is worth. Okay, don't just try and round up. Draw a line of best fit. Remember, the line of best fit has to fit the pattern of the data. So it could be a straight line or it could be a curve. You have to make a judgment on that. And remember that it is one straight line. Okay, it's not a little sketch like you might have done in art. It's one continuous straight line that is as thin as possible. The next thing to remember about graphs is when we are interpreting our graphs, we have to think about the patterns that we see. And again, this comes down to our exam technique, looking at how many marks our graph question is worth. If it's worth 1 mark, you might be able to put a simple answer as that one variable increases as another variable increases. However, if it's 2 or more marks, you're going to be looking for more information. Is there a particular value or piece of data where the pattern in the graph changes? Are you comparing 2 lines to each other? And if you are, is there something that they've got in common, a similarity? And is there something that's different about them? So think about building up the level of difficulty of your answer for our graph questions. So equations are a big part of our physics exam. So we need to make sure that we're doing correct exam technique to make the most of those equation questions. Because when we get them right, they're a really easy way to pick up marks in physics. So the first thing to do with your equations questions is at the start of the exam, before you even look at any questions, you will be given an equation sheet with 12 equations on that you don't need to remember. Underneath those 12 equations, write down all the equations that you've remembered from your revision. So you're making yourself your own equation sheet. This makes it easier for you to choose a particular equation when you're answering an exam question. So then when it comes to the exam question, the first thing to do is when you're reading through the question, identify the variables that you've been given and write them down at the side of where you're going to write your answer. So you identify what variables you've got and what variable you need to calculate. Then you can go to your equation sheet and solve the equation that includes those variables. Once you've found that equation, write your equation down first, either in words or symbols, it doesn't matter which. Then look through your question. Do you need to convert any units? So remember, all our answers should be in standard units. If you need to do any conversions, do these separately to your main calculation for your equation. Then, when you've done those conversions, substitute the numbers into the equation, rearrange the equation if you need to, calculate the answer, and then look at the answer line in the question. If there isn't a unit given, you need to state the unit if you need to, remembering that some variables don't have a unit at all. Now, as you move through the paper and you get towards the end of the paper, there will be a question on your exam that's a calculation question that's worth 5 marks. These questions often require you to use more than one equation. So The way that you identify this question is, one, it will be worth 5 marks, and 2, then when you're writing that list of variables at the beginning and you're looking for an equation, you'll probably identify an equation that you need to use, but you don't have all of the variables for that equation. So you find out the variable that you've got missing, and then you find another equation that allows you to calculate that variable. You then calculate the missing variable and then substitute that into your other equation. So you're going to need more than one equation. Sometimes it might be 2 or 3 equations for these type of questions. So these are a list of the physics equations. Make sure you memorize them. Again, you can do it in word or symbol form. If you're not sure of the symbols, make sure that you write the words out, because if you use an incorrect symbol, you will lose the mark for that equation. So lastly, some little hints and tips for each topic that we've got. For our energy topic, make sure we're linking energy transfers to our energy stores. And remember, an energy transfer could be moving the energy from the same type of store, but you're moving it from one place to another. So we're not necessarily involving an energy store change. Make sure in your descriptions that you use work done. Remember, work done is transfer in energy, or the amount of energy that's transferred. The next point, when an object is falling or an object is moving upwards or rising, if there's no air resistance or friction, and it will specifically say this in the question, then all of our gravitational potential energy is converted into kinetic energy, and you can set those 2 equations equal to each other. That's a really common question that comes up on a lot of papers. Last thing about the energy part is that energy efficiency can be calculated using energy or power. We've got both equations, and it has no unit, so be really careful with that. You will lose a mark if you put a unit with energy efficiency. Electricity. Most important part of the electricity topic is Ohm's law and the graphs that come from Ohm's law. That's one of our required practicals on our required practical sheets. If in doubt when you're looking at an electricity question, use the equation V equals IR. Most of electricity works around that equation. The other thing that you need to learn are the rules for current and potential difference for series and parallel circuits. They will help you apply that V equals IR equation. For the particle model of matter, a little bit like with energy where we said link everything back to work done, for particle model of matter, we need to link all our explanations back to the way that our particles are arranged or the way that the particles in our object are moving. So that kinetic theory of how particles are arranged and moving in solids, liquids and gases is really important. When heating an object, always state how the internal energy is changing. Is it increasing or decreasing? Which part of internal energy, the kinetic or the potential energy, is changing? Remember, if you're doing calculations, if we're increasing the temperature, then we'll be using the specific heat capacity equation. If we're changing state, we're going to be using specific latent heat. And the last part of the particle model section is knowing how to use the equation PV equals constant for pressure and volume. So the last topic, atomic structure and radiation. Know the properties of the 3 types of radiation, alpha, beta and gamma. Know the difference between radioactive decay and nuclear fission and nuclear fusion. Those often get confused. In your answers, always refer to the nucleus, not the atom. Whether it's radioactive decay, fission or fusion, we're looking at changes in the nucleus, not changes to an atom. Know how to calculate half-life from a graph and from data. Be specific with your answer. Don't round up, especially on a graph. Okay, if it's 2 points past the scale line, make sure you work out how much value that 2 points is and make sure that you give that specific answer, unless the question asks for an integer number, a particular number of days or a whole number of years. And with that, check out the unit as well. Do they want your answer in seconds, minutes, days, hours, years? Okay. Good luck with your exams, and I hope this PowerPoint has helped you.